The shaped charge, or jet perforator, first came into use in the oil field in the 1950s, following the development of explosive technology during the Second World War. The four important components of the shaped charge are the conical metallic liner, the main explosive charge, the primer explosive, and the case that encloses the charge.
Simply stated, the firing is electrically initiated by the detonator or blasting cap via the detonating cord, which in turn sets off the main charge. Explosive pressure on the metal liner causes it to collapse inwardly along its axis, forming a high-velocity jet of fluidized metal. Moving at a velocity of 25,000 feet per second and with a pressure of 15 million pounds per square inch, the jet displaces the casing, cement, and formation, creating a perforation in only several hundred microseconds.
Depending on the design of the shaped charge and the type of materials being perforated, the perforation length is generally about 2 to 20 inches, 5 to 50 centimeters, and the entrance hole diameter about 0.2 to 1 inch, or 0.5 to 2.5 centimeters. There is a zone of crushed rock around the perforation, and the precise shape of the perforation will vary somewhat depending on charge geometry, gun positioning, and target characteristics.
For example, although the exterior of these charges look identical, this charge is designed to give large diameter perforations for easy gravel packing, while this charge is designed to penetrate deeply with a somewhat smaller entrance hole. Here we see a charge that is designed to be run in a 6-inch or 7 1/4-inch diameter carrier, while this charge is made for a 1 11/16-inch carrier. There is quite a bit less explosive power in this smaller charge, but that power can still be focused on maximizing hole size or penetration, depending on the needs of the completion.
The position of the gun in the casing is another important parameter in determining the size of the perforation. Gun clearance is the distance from the casing inner surface to the gun. Penetration and hole size generally decrease as clearance increases.
This issue is particularly important when small diameter guns are run through tubing into larger diameter casing. In such situations, the gun needs to be positioned against the side of the casing to create a single line of deep perforations. This arrangement, called zero-degree phasing, may introduce an undesirable pressure drop in high-rate wells. Phasing the charges at 60, 90, 120, or 180 degrees would reduce this problem, but at the price of reduced penetration and hole diameter when using through-tubing guns.
The third most important factor in shaped charge performance is the strength of the target material. For example, a charge that penetrates 5 inches into the Berea sandstone target shown here will only penetrate 2 inches in a much stronger sandstone. In deep reservoirs where the formation effective stress is great, the penetration depth may be much less than surface tests indicate, and this factor must be considered when choosing a perforator.
Charge performance is also affected by the quality control applied during its manufacture, where precise control of the liner and charge dimensions is critical. The care with which the charges are stored and transported is also quite important. Charges should be stored in sealed boxes until ready for use. Correct alignment of the shaped charges within the charge carrier, whether it be a semi-expendable strip carrier, a port plug gun, or any of several types of scallop guns, is a very important final step in the gun assembly process. The added cost of quality control in manufacture and assembly is a wise completion investment.